In this new video, we'll continue with the slides of SMAW electrodes. Okay, so this MMA electrodes, this one it contains cellulose or organic material. This it will produce a gas shield high in hydrogen, and it will helps in the raising the arc voltage. And it can give us a deep penetration and fusion characteristics, and welding at high speed without any risk of lack of fusion. And it forms a thin slag layer with a coarse weld profile. Does not require baking or drying, and also this excessive heat will damage the electrode covering. Like baking will make it in the electrode covering. It is mainly used for stovepipe welding, that we'll see later. And the hydrogen content is 80 to 90 ml per 100 gram of weld metal. And one disadvantage is generate high level of fumes and S2 cold cracking. Hydrogen cold cracking can be observed, so it's a negative point. Now we'll listen what is this stovepipe welding. Stovepipe welding is a common term for shield metal arc welding process in a large-scale cross-country pipeline construction, especially when using a high-speed vertical down technique with cellulose electrodes. In this technique, welders join sections of pipe which are fixed horizontally by moving around the pipe in a vertical downward direction. This process involves multiple passes like root pass, hot pass, filler pass, and capping layers. A skilled worker lays the first most critical pass, that is a root pass, to fill the gap between the pipe sections using a deep penetrating arc and a faster travel speed. Then the hot pass. This immediately follows the root pass, is run hot enough to refine the root and burn out any potential slag, reducing the risk of defects. Filler and capping passes, subsequent passes, fill the rest of the groove and create the final protective layer of the weld. This method is highly prized for its exceptional speed and portability. Occupation is simple. It does not require external shielding gas that would have been easily disrupted by a wind and in the open field conditions. So why this name stovepipe came? The technique of stabbing or joining one section of pipe to the other end is similar to how sections of a metal wood stovepipe is fitted together when assembling a chimney or exhaust system. This technique is strongly associated with the vertical down welding progression used in a pipeline construction. So it allows the entire pipeline to be laid quickly in an assembly line fashion. It is just like assembling a series of stovepipes end to end. Over the years, the term became a general nickname for the cross-country pipeline welding. It employs a high-speed vertical down methods, especially using cellulose electrodes. So the stovepipe welding is primarily used in a shield metal arc welding to join large diameter pipes, that's for such as for oil and gas and water. It involves welding vertically down the pipe using high hydrogen cellulose electrodes, with the process being split between two welders working on the opposite sides of the weld to speed up the pipeline construction. Its key advantage is speed for the large projects, but main drawback is the slower overall productivity compared to some automated process. The process uses a vertical down technique or stovepipe technique. This involves melting the electrode with an electric iron to join the pipe sections. Two welders work simultaneously on the opposite sides of the pipe, one starting at the top, other at the bottom. Key features are probabilities. Highly probable method does not require shielding gas or flux. It makes ideal for a cross-country pipeline production. Vertical down method, particularly with the cellulose rods, allows very fast welding. Though overall travel speed can be slower than the other techniques. Method is portable, uses simple equipment. Speed is crucial for large scale pipeline projects. Despite the speed of the technique itself, the productivity can be lower to other methods due to manual nature of the work and the slower overall speed. Okay. So speed should be critical, like along with the speed of the ditching, hauling, stringing, etc. So it is your positional welding enables steel pipes to be laid at high production rates. In the pipe welding, rate of joining is limited by the root pass and the hot pass. In order to speed up the deposition of this root pass without compromising the quality of the weld, the welding is carried out downwards from 12 o'clock to 6 o'clock, since the process is faster than the upward direction, especially for the pipes of wall thickness below 25 mm. Furthermore, this allows the use of two pair of welders working simultaneously on both sides of the pipes as opposed to only one pair. This coating also provides a shield gas, this cellulose coating. The weld preparation consists of 60 to 70 bevel inclusive angle, in 1 to 2 mm root face and 2 to 3 mm root gap. Stringer beads are deposited into the root of high speeds 250 to 300 mm per minute. It is immediately followed by a hot pass. It refines the root pass. It reduces the risk of hydrogen cracking associated with these consumables. A minimum level of preheat may be required for the same reason. The filler, stripper and capping runs complete the welding. The welding is usually performed by a team of welders. A larger the pipe, greater the number of the welders. In most cases, each welder performs the same weld runs on each successive joint. Now we need to discuss root face. So, why in MIRFA we are not using root faces, and I asked Sari sir why. He said that it is not strictly mandatory, he told. So this is also saying that it is not strictly mandatory. Some joints such as feather edge preparations or open root joints are designed without one. But inclusion is a crucial dimension in most groove weld designs. It's considered as a essential variable in the welding procedure. So root face or land, it is a unbeveled portion of the root of the joint. Its primary functions is controlling the penetration and providing a foundation and managing the heat input. Controlling the penetration means the thickness of the root face helps control the depth of fusion, prevents burn through or excessive penetration to the molten weld metal, especially in open root welds. And foundation means it has a stable base of the first. It offers a stable base for the root pass. It makes it easier to control the weld puddle, ensure proper alignment of the parts. Managing heat input. A previously sized root helps dissipate the excessive heat in the root area. Factors is determining if the root pass is used. Welding procedure specification. All root dimensions, particularly including the root gap and the root face, are defined in the qualified WPS. What's the first thing? Joint design. Some specialized preparations like U and J grooves are specially machined with a root face. Conversely, a open root V groove can be welded without any root face, but it requires greater skill and slower, more costly process to avoid the defects. It is very difficult to avoid defects if there is no root face, particularly the excessive penetration or burn through. So primary function of a root face to avoid the burn through or excessive penetration. So thicker material often utilize a use face, sometimes in conjunction with a large root gap to manage the amount of weld metal needed. So if there is a root face like this is the root face. If there is no root face, the weld joint will be like this, and it will require more weld metal. Secondly, excessive penetration. If the joint is like this, here chances that there will be burnout or excessive penetration. So root face prevents this actually. So code requirements. Some industrial codes and standards, that's AWSD 1.1 and ASME section 9, may have specific requirements or pre-qualified joint designs that dictate the use and size of a root face. And root face dimensions are compromised between. So there are 2 points. But it's minimize. We have to minimize the stalled total weld volume. Second is achieving an adequate access to the for the electrode. This is there should be a compromise between these two. So root face finance dimensions are a compromise between these, achieving a adequate access to the rod and minimizing the total weld volume. In short, not universally mandatory in theory in factories, a root face is a standard and critical element of joint preparation for a solid, high quality SMAW groove welds unless a specific qualified procedure without one is being followed. Okay, now what first slide is completed, we will go to next slide. Again, we have this cellular. We are going to discuss the disk advantages. It have high electron, so the risk of hydrogen induced cracking. Need to keep the joint hot during the welding to allow edge to escape. No, so there should not be a rapid cooling, and there otherwise crack will appear. It is not suitable for high strength steels. Cracking risk too high may not be allowed for grades stronger than X70. Okay, not suitable for very thick sections. So we are using it only for the root gap because of this high hydrogen content. Cracking problem is there. Not suitable with low temperature toughness is required. So we are using only in the root pass. Otherwise, this impact toughness will give effect satisfactorily down to minus 20 degree, plus or minus 20 degree. Now we will discuss some advantages of the cellulose electrodes. First advantage is that it is offers a deep penetration and fusion. It is suitable for all welding positions because it is a fast freezing electrode. We can do overcut without without the weld pole falling off the joint by gravity. Before that button occurs, it freezes itself. So faster travel speeds. large volume of shielding gas can be generated by these cellulose electrodes. Shielding gas by burning out the flux, it is already included. Low control is needed. What is the disorder? It is high in hydrogen and it can cause high crack tendency, rough weld appearance, high spatter contents, low deposition rates. This spatter we already discussed is bubble like formations in the weld pool. So low deposition is low deposition rates. Okay, that we understand because it is meant for fast freezing and we have to move faster. That's why it is has got a low deposit. And also we have other electrodes like E7018 for this high deposition rates. Now we will discuss the basic electrode coverings. Particularly we are using in this E7018. It produces a convex weld profile. It produces thicker slags and very uh, difficult to detach the slags. We can use it for high pressure work, thicker section metal, and high strength steels also. Electrons should be baked typically 350 degree for 2 hours to reduce the moisture to a very low levels and achieve low hydrogen potential status. They have low hydrogen iron powder coatings actually. It contains calcium fluoride and calcium carbonate compounds. Cannot be baked indefinitely. Low hydrogen potential gives gives weld metal very good toughness and yield strength. Have low levels of hydrogen less than 5 ml per 100 gram of a weld metal. So particularly it produces a common weld profile as a summary, difficult to detach for high pressure work, thicker section steel, high strength steels. We can bake should be baked typically 350 degrees Celsius for 2 hours plus to reduce moisture to very low levels to achieve low hydrogen potential status. It contains calcium fluoride and calcium carbonate compounds. It cannot be rebaked indefinitely. Low hydrogen potential gives weld metal very good toughness and yield strength. Have a lowest level of hydrogen less than 5 ml per 100 gram of weld metal. So we have some disadvantages listed for the basic electrodes. One is a careful control of baking. Careful control for the baking and issue of electrodes is essential to maintain low hydrogen status. Baking temperature is 350 degree 1 to 2 hours. Holding temperature is 120 to 150. Issue in heated cuvers. Weld profile is more convex. Deslagging requires more effort than other types. So, careful control of baking is required to maintain the low hydrogen status to avoid risk of cracking. baking temperature should be 350 degree for 1 to 2 hours. Then holding temperature is there 120 to 150 hours. The heater QL should be typically 70 degrees Celsius. So these are the careful control required for baking. And weld profile is usually more convex, means larger deposition rates. And actually, ideal situation is that uh, support is the toe line. Suppose it is the suppose it's the toe line, then the welding should be slightly convex and not more than that. If it is like this, there are chances of stress concentration will happen there at the toe. So this profile usually provides more convex, and deslagging requires more effort. That means deslagging means the removal of slag. It will produce thicker slabs, and hence it is very some little more difficult to remove than the cellulose electrodes we are using in the root pass. Okay. So in summary, basic electrodes we have advantages: high toughness values, low hydrogen contents, low crack tendency, but the disadvantage is high cost, high control, high welding skill required, and convex weld profiles, and poor stop starter properties points. Okay, these are the summary of advantages and disadvantages of basic electrodes. Okay. Now we have the electrode designation we already discussed. E stand for covered electrode. Tensile strength is in PSI. 60 KSI means 60 into 10 into 1000 PSI. It is the one position. One means all position. Two and four is two for flat and horizontal positions, and four is vertical positions. And flux coating is a 3. 3 means actually we are discussed 0 and 8. 3 I don't know. 0 means a cellulose coating, and 8 means low hydrogen iron oxide coating, iron powder coating. Okay. Now this one we also discuss. We have types of electrode for this chromium, magnesium, steels. We have cellulose concrete, rutile heavy coated, and H basic. Cellulose means 0 and 1. Here BSEN for double is C. Rutile means R. Rutile heavy coated means double R. B means basic. And we are using cellulose concrete 6010 and 7018. It is basic electrodes that we discuss. Low hydrogen iron powder, and in the BSEN 4449 it is a B only. Basic for B. Rutile means R. Double R means heavy coated. Okay. This rutile we are using for furniture welding and all. General electrode, it is very easy to control. And this is a we need to know as a general knowledge what is electrode efficiency. Electrode efficiency means is the efficiency mass of weld material deposited by mass of core wire melted. So it is 75 to 90% for usual electrodes, and up to 180 for iron powder electrodes. Okay. Okay. Now we will discuss some electrode treatments. how we are treating the electrode before using. Use a straight from the box, no backing or baking or drying. Retail vacuum packed basic rods use straight from the pack within 4 hours. No rebaking. Okay, we already discussed how to rebake it. We have to do it in a 350 degrees Celsius for 1 to 2 hours, then hold it for some 100 degrees Celsius for 1 hour. So after this there is no rebaking. We can use the straight from the pack with it is vacuum packed basic electrodes. We can use straight from the pack within 4 hours, and this pack has 70 degrees Celsius temperature. And rutile electrodes dry up to 120 degree, no baking. It is only drying up because uh, if we are baking it, it will be cause damage to the electrode. Okay. Now we will discuss baking of these basic electrodes. So it is baked for oven for 2 hours at 350 degrees Celsius. After baking, maintain in oven at for 150 degrees Celsius. Uh, you use from QVS at 75 degrees Celsius. And if not used within 4 hours, return to the oven and rebake. The number of rebake is limited. No, actually there should be no rebakes. So whatever after breaking, whatever left should be discarded actually. Okay. So the tungsten inert gas. In this one, we are using filler wires, shielding gases, tungsten electrodes, etc. It is not consumable. The filler gas of different materials composition, variable diameters available in standard length, with the applicable code stamped for identification. The filler wires of very high quality, copper coating is there to resist corrosion. This shielding gas mainly argon and helium, which is supplied along to the nozzle. It is of the highest purity, 99.9%. Okay. Now, so in this micmac welding consumable, we can see it is a carbon and low alloy wires. It is copper coated, and the stainless steel wires are not coated, and the flux core wires does not require baking or drying. Okay. So it is the final this one of the electrode, slide in the electrode, flux core flux core wire consumables. Here it is the flux core. It provides a form stability as as a current transfer during welding. So it will transfer current to the base material, to the arc, to produce the arc, stabilize the arc, add alloy elements, produce gases, shield, produce slag, and add iron powder. So this is the things we already discussed. Just for a we can use it as a revision. Okay, thank you.